Hello grade 10 students, welcome to this video lesson. I am Madhu Vadke. We continue with chapter 4, quadratic equations. In previous class we studied how to find the solution of quadratic equation using the method of completing squares. We will extend the idea of what we studied in the last video class to find a direct formula that can be used to find the solution. This direct formula is called as quadratic formula. So in this video class we will learn about quadratic formula. So let us derive the quadratic formula. The method to derive quadratic formula is based on the method of completing squares. So we are going to follow the steps that we had learned in the previous class. We will start by writing a quadratic equation in its general form. Ax square plus bx plus c equal to 0, where a is not equal to 0. So the first step in method of completing square was to divide the equation by coefficient of x square, that is a. So we get x square plus b upon ax plus c upon a equal to 0. Now we shift the constant term to the right side. So x square plus b upon ax is equal to minus c upon a. Now we need to write the left side of the equation in the form a square plus 2ab plus b square, so that we can write the left side as a plus b the whole square. I am using capital A and capital B to distinguish from the coefficients of the quadratic equation that we are using. So a is x. To find b, we will have to equate the x terms of these two equations, or the middle term of these two equations. So in the rough column, 2 capital A B is equal to b upon a x, but capital A is x, so I am going to replace capital A by x and b needs to be found. So capital B is equal to b upon 2a. So capital B is equal to b upon 2a. Now we can write equation 1 as x square plus b upon ax plus b upon 2a square. This is the capital B square term, equal to minus c upon a. Since we have added something to the left hand side, we will add the same number to the right hand side. So minus c upon a plus b upon 2a whole square. So the left hand side becomes x plus b upon 2a whole square equal to minus c upon a plus b square upon 4 a square. Adding the right side, the LCM is 4a square. The first term will be 4a times minus ac, that is minus 4ac. How did we get this? Dividing the denominator 4a square by the denominator a, we get 4a. That 4a is multiplied to minus c. Next term plus b square, because 4a square divided by 4a square is 1 and 1 multiplied by b square is b square. So x plus b upon 2a whole square is equal to b square minus 4ac divided by 4a square. Now we take the square root of both sides. We get x plus b upon 2a equal to square root of b square minus 4ac upon 4a square with the plus and minus sign. But square root of 4a square can be written as 2a because 4a square is a perfect square. So x plus b upon 2a is equal to plus minus square root of b square minus 4ac divided by 2a. Now shifting b upon 2a to the right side. So we get x equal to minus b upon 2a plus minus root of b square minus 4ac divided by 2a. We can add these two terms, minus b plus minus root of b square minus 4ac divided by 2a. So this is the quadratic formula, which is in terms of the coefficient of x, x square, and the constant of the quadratic equation. The term inside the root, that is b square minus 4ac, is called as discriminant, which is denoted by capital D. So discriminant is equal to b square minus 4ac. So we can write the same formula, x equal to minus b plus minus square root of d upon 2a. Since we are dealing with quadratic equation, there are two roots of this equation. So one root is minus b plus root d upon 2a, and the other root is minus b minus root d upon 2a. With this knowledge, let's start solving some problems to find the roots of given quadratic equations. This is a problem taken from exercise 4.3, question number 3. Find the roots of following equation. The first step is always to write the given equation in the standard form. So we will multiply this equation by x. So we will get x square minus 1 equal to 3x. So x square minus 3x minus 1 is equal to 0. Before using the quadratic formula, we have to write down the values of a, b, and c. So a in this equation is 1, b is minus 3, and c is minus 1. So using the formula, x equal to minus b plus minus root b square minus 4ac upon 2a. Always write down the formula, because in case you go wrong in substituting the value or calculation later on, you at least get marks for the formula in your answer. So this is equal to minus, this minus is the minus sign of the formula. So we copy it as it is. B is minus 3. So we write it in the bracket, plus minus root minus 3 square minus 4 times 1 into minus 1 divided by 2 times 1. Now we will simplify these numbers. So we get plus 3 plus minus root of 9 minus 4 into minus 1 will be plus 4 divided by 2. So this is same as 3 plus minus root 13 upon 2. So the roots of this equation are 3 plus root 13 upon 2, and the other root is 3 minus root 13 upon 2. This is the second problem of the same question. So let us reduce the equation to the standard form. Simplifying the left hand side, we multiply the denominators, x plus 4 times x minus 7. Then to get the numerator, we cross multiply. So x minus 7 minus x plus 4. Now keep x plus 4 in bracket because there is a minus sign before it, equal to 11 upon 30. Now simplifying the numerator and denominator on the left hand side, x minus 7 minus x minus 4. When you open the bracket, the signs of the terms inside will change because there is a minus sign before the bracket. Multiplying the terms in the denominator, x square minus 7x plus 4x minus 28 equal to 11 on 30. So x minus x becomes 0, minus 7 and minus 4 gives us minus 11, x square, adding the like terms, minus 3x minus 28 is equal to 11 on 30. Now we can see that the numerator has a common factor, that is 11. So we can divide both sides by 11. So we get minus 1 upon x square minus 3x minus 28 equal to 1 on 30. Now we cross multiply. So minus 30 is equal to x square minus 3x minus 28. Now we can carry minus 30 to the right side. So x square minus 3x plus 2. This is the given equation in standard form. Now we can use the quadratic formula. So we write down the values of a, b and c. A is 1, b is minus 3 and c is plus 2. So x is equal to minus b plus minus root b square minus 4ac divided by 2a. So minus 3, substituting these values, plus minus root minus 3 square minus 4 times 1 into 2 whole divided by 2 times 1. Now simplify 3 plus minus under root 9 minus 8 divided by 2. 9 minus 8 is 1 and square root of 1 is 1. So 3 plus minus 1 divided by 2. So the two roots are 3 plus 1 divided by 2 and 3 minus 1 divided by 2. On simplifying, we get x equal to 2 and x equal to 1. This is question number 4 of the third exercise of this chapter. The sum of reciprocal of Rahman's age in years 3 years ago and 5 years from now is 1 on 3. Find his present age. Let the present age be X years. Therefore, what will be his age 3 years ago? Three less in x, so that is x minus 3. Then what will be his age 5 years from now? We will add 5 to his present age. Now the sum of reciprocal of these ages is equal to 1 on 3. Reciprocal of x minus 3 is 1 on x minus 3. Reciprocal of x plus 5 is 1 over x plus 5, and the sum of these reciprocals is equal to 1 on 3. So we have represented this word problem in terms of an equation. The next step is to write it in the standard form. So we add the left hand sides. To add the left hand sides, we multiply the denominators. So x minus 3 into x plus 5. To get the numerator, we cross multiply. X plus 5 plus x minus 3 equal to 1 on 3. Now simplifying the left hand side expression, x plus 5 plus x minus 3 divided by x square plus 5x minus 3x minus 15 is equal to 1 on 3. So x and x terms will add up. So we get 2x plus 2 divided by x square plus 2x minus 15 equal to 1 on 3. Now we need to cross multiply. So we get 6x plus 6 equal to x square plus 2x minus 15. I am taking 6x plus 6 to the other side and writing the other side on the left side. So x square plus 2x minus 15 minus 6x minus 6 is equal to 0. Adding like terms, x square minus 4x minus 21 is equal to 0. Now we can solve this question by any method that we have studied. So let's use factorization. The product will be minus 21. Factors of minus 21 will be minus 7 and plus 3. That will give a sum minus 4 and product minus 21. So the factors are x minus 7 and x plus 3. Equating each bracket to 0, we get x equal to 7 and x equal to minus 3. Now since this is an age question, age cannot be negative. So the answer is 7. So Rahman's age is 7 years. This is also one of the questions from the same exercise 4.3. In a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the 2 subjects. The sum of marks obtained in maths and English is 30. So if we represent marks obtained in mathematics by X, then marks in English can be written in terms of marks obtained in mathematics. So let marks obtained in mathematics be X. Therefore, marks obtained in English will be sum minus marks obtained in mathematics, 30 minus X. Had she got 2 marks more in mathematics? So let's write down the new marks in maths. X plus 2 and 3 marks less in English. So new marks in English will be 30 minus X minus 3. So that is 27 minus X. The product of these marks would have been 210. The product of new marks. So X plus 2 into 27 minus X will be equal to 210. Now we write this equation in the standard form. So simplifying, 27x minus x square plus 54 minus 2x is equal to 210 minus x square plus 25x, carrying 210 to the left side and adding with 54, we get minus 156. Changing the signs throughout, so x square minus 25x plus 156 is equal to 0. This is in the standard form. Now we can solve this equation to find out x. Use any method that you are comfortable with. When you have such big numbers like 156 in this case, it's better to use the method of factorization instead of quadratic formula. So the product here is plus 156. Find the factors of 156. Since it is even number, we start with 2 into 78. Then we can further split the factors. 78 can be written as 3 into 26. Since we want the sum to be minus 25, we will have to factorize further. 26 can be written as 13 into 2. Now if we multiply 2 into 3 into 2, we get 12 and 13 as two factors which add up to 25. So both numbers should be negative. So their product will be plus 156. So the factors are x minus 12 and x minus 13. On equating each bracket to 0, we get x equal to 12 and x equal to 13. Now which one is the answer? In this particular question, both answers are acceptable, because if marks in maths, which is represented by x, is 12, then marks in English will be 30 minus x, that is 18. If marks in maths are 13, then marks in English will be 30 minus x, that is 17. Both answers are acceptable. With this, we come to the end of this video lesson. Your assignment for today is exercise 4.3, question number 2. Find the roots of quadratic equations given in question number 1 above by applying the quadratic formula. See you in the next class with some more concepts related to quadratic equations. Until then, goodbye.